Okay, welcome again. This will be the first talk today. The title is Invisible Infrastructures by Andrej Petrovski from Share Foundation. Please greet him and enjoy the talk.
Hello, everybody. Hope you can hear me well. Who here feels comfortable walking in English? I mean, just so that I know how fast and how profound, how deep can I go with terminology. Do you all speak English good enough? Yeah? Okay, great. My name is Andrej Petrovski. I come from Share Foundation. And this is my colleague Vladan Joler, also from Share Foundation. He is a local here from Novi Sad. I come from Belgrade. Today we are going to talk about, I hope that you're all enjoying yourself and that you like the conference. I personally like it very much. And my talk today, our talk today, will be about invisible infrastructures, or as this subtitle here says, postcards from internet. Each and every one of us uses internet on a daily basis, but not as many of us are aware of how the internet actually works. And even those of us who know, because there are some hackers here as far as I know, even those who know how the internet works have some issues with the physical aspect of the internet. They don't really know the actual points where their traffic passes. This is why we in Share Foundation did a research to check all the points or the places where the Serbian internet lives. I hope that you'll enjoy this presentation. It has amazing visualizations done by my colleague Vladan here, and sit back and enjoy. This is the essence of the internet. Is some of you have done this at some point. It's called trace routing. Trace routing is a special service or a tool which is integrated in most operating systems using ICMP protocol to trace the hops of the internet. Basically, it tracks the packet from one point in the internet, which is your computer, to some server or a website. So basically, traceroute is quite a useful tool in network diagnostics, but also we use it as a tool for research in order to be able to see the entire or most of the Serbian network. I just want to make you aware that if you are connected to a ISP, Internet Service Provider in Serbia, chances are that in the past year or so, me or Vladan have knocked on your router at some point because we took all the IP ranges that are publicly available for Serbia and trace routed all of the IP addresses available. So the internet basically works based on packets, IP packets, which are structured in some logical way. Just a general idea is that they contain a header or part with metadata and content, part which contains the actual content of the packet. I don't know how many of you are familiar with the term metadata. So metadata are data about data, or data that explain what the actual data is about. You can think of it as when you send a letter by post. Nobody does that anymore, but I'm sure you remember how it's done. Basically, you have a letter that you write, you put it in an envelope, and then on the envelope you write some addresses, your address, the address of the receiver, some stamps, etc. So think of the header of the IP packet as the envelope or the outside part, which contains the addresses and some other information that makes sure that the letter makes the right address. Or in case if it's the receiver doesn't want to receive the letter, it comes back to you. There are many cool things about these IP packets, but what we are going to talk about today is where these packets go and where these packets stored on this journey from Serbia or from Belgrade, Novi Sad, wherever, to some server, in this case, Facebook server in the USA. The first jump the IP packet makes when it's generated by your browser is to your router at home. That's the black or white box that gives you internet. Then it goes to some local, let's say, center that's set up by your ISP that gathers all the traffic from your neighborhood, let's say. And then it goes to this building in Belgrade. It's SBB Telepark. This is for the ISP SBB, which we base our, I'm on SBB, so that's why the research is based on that provider. Anyways, in this building, all the packets generated by SBB users are collected. Afterwards, the packet jumps to this building somewhere in Germany, in Frankfurt, more precisely. Frankfurt in Europe is the biggest internet exchange point. Internet exchange point is a point in the network where many ISPs merge, and all their packets come to this place, and then they're routed to some other places. So actually, this is one of the biggest peering points in Europe. It's a cool building with a nice park, and it's blurred because it's considered a building of national interest for Germany, so you can't really see all the sides of the building. You can just have a picture from afar. These are, by the way, Google Street pictures, yeah. Afterwards, it goes to Dublin in Ireland, in the Republic of Ireland, where it gets copied and just routed away. There is this cool place in the UK, which back in the hippie days was a really famous surfing place where people went to surf on these boards. It's called Gchq. It's on the west coast of the United Kingdom. And this is a cool place because this is the point where the European traffic leaves Europe, or it goes to the US. Quite nearby, this is the hub in Gchq where actually the routers and the servers are located. This is also a really cool place. It's called the Gchq Farm. The Gchq is, I don't know if many of you know, the intelligence agency of the United Kingdom. And it's in Bute. It's just a couple of tens of kilometers away from Gchq. So the intelligence agency, by chance, put their biggest satellite farm near the point where the European traffic leaves Europe. Now, after it dives under the Atlantic, goes into this fiber cable, it goes to the U.S. This is in Tuckerton in New Jersey, the landing point of the European internet. Basically, if we have Gchq on the one side that constantly sends packets and receives, of course, we have the Tuckerton on the east coast of the US that receives European traffic. This is what's known as the first capital of the internet. It's Equinix, the first place where a huge amount of data was gathered. But nowadays there are even bigger ones. It still works. I mean, it's quite big. You can see by the parking around. And it reaches the destination, which is the Facebook data center in Forest City in North Carolina in the U.S. Something worth noting about this building is that Facebook cannot build it fast enough to host all the servers they use, so they constantly buy new land and build the place, which on the inside looks like this. There are no people here. There are just 80 people working in this humongous building that basically what they do is they change batteries and they change some spare parts. There's no light inside. Light automatically turns on if there is a problem at some server. So it's practically quite a ghost city, the humanized building. Not a nice place to be, but it is here where all your Facebook photos and chats and statuses are. So next time when you type a status or post a photo, you just bear in mind that it slips somewhere around here. Another important thing to note is that even when the packet dies, so to speak, or it's completed its mission in life, and that's to reach from Novi Sad to the Facebook data center in the US, it doesn't actually die. It goes to hibernate maybe, and it's further analyzed and cloned in the future as well, for purposes of data analytics, etc. Can you give a voice to Vladan as well?
Just to maybe explain in some other way. What Andrej explained now, it's basically happening in less than 1 second. Okay, when you type www.facebook.com, in this moment, this tiny little packet is going through all of these countries, is going through all of these different gray buildings, and finishing in this place at the end. And what is really important for us is that, like, why we are not aware of this process, because it's so fast and it's so invisible. And our goal with this research was to try to understand what's going on behind. So every time when you type www.facebook.com, this is what is going on. And now we will continue further to...
Yeah, just a couple of other details that on the way, in most of these countries, the packet gets copied and stored. Depends on the law in the certain country. It varies from 6 months to 2 years. That's at least in the European Union. Even though the directive of the EU that deals with retaining data, or with more simple words, retaining information about what some visitor from Serbia has browsed on the web, even though the directive that regulates that in the EU is declared unlawful, there are really many countries in the EU that still do that, and the US, of course. The next step was, okay, we saw the route of the packet from Serbia to the US. Now let's see what's going on in Serbia. Like, we don't really have a map of our own country representing all the servers and the points in the network that are of vital importance. For that, we needed to see who has what part of the market, and what we found out is that it's not really super hard to find out. You just get the IP ranges and see who has how many IP addresses.
So to put things on the lower level, every device that is connected to the internet have an IP address, okay? So this is this 180. Okay. How we can know that those IP addresses belong to someone in Serbia? Because there is like an organization who is distributing by countries ranges of IP addresses. So they are saying, from this number to that number, this is all the devices that will be assigned to the different hardware, like computers or routers in Serbia. And then those numbers, those IP addresses, are separated to different internet service providers. Telekom Serbia get one range, SBB get another range, Orion get third range, and so on. And then at the end, when you're using internet, basically you are using one of those IP addresses that are assigned to internet service provider that took those IP addresses from
RIPE, basically, because RIPE is the European Register of IP addresses. That's why you have maybe noticed that sometimes when you watch YouTube, it says this video is not available in your country. That's how actually the YouTube server knows that you're in Serbia. There are also other ways, but basically that's the most common way to see where you're located. So Telekom Serbia has the biggest portion of the IP address space assigned to Serbia. Then it's SBB and some other providers. What you're going to see now are logical maps. So they're not physical like land map, but logical maps of the internet of Serbia. And what I want you to think about is the concentration of the points of the hosts at every of these maps.
What we did, basically, we took all of those IP addresses, okay, and we created little packets that went to your computer, visit your computer, and told us through which other points this packet came to your computer. On the way back, we get information about this trace, and then we used different softwares for data visualization to make maps. And this is what you're going to see.
And they're really cool.
So this is one provider called Absolute OK. It's one of the smaller ones. This is Orion. It looks like space. And this is Telekom Serbia.
Yeah, just remember this one. This is Amres.
Amres is university network.
Yeah, the university, the internet that you use at your university is part of the Amres network. This is the Post, PTT, Verat, Beotel, Exenet, SBB, one of the second largest one, basically. So this is a map representing each and every one of them. A different color represents another ISP. So, and these points where you have bigger concentration are their core points. And there in the middle, you can see the points where they are all, where they connect between each other.
Can we go back on telecom? So, yeah. But, okay, except of this like a visual part of the thingy, that it looks like really cool and it's like a space. The question is what we can do about that, how we can read those maps. The main thing here is that you can see, for example, two big balls. And that means that in the middle of those balls there is like one or few IP addresses, that means like servers, that all the data, all the other routers or servers that are connected in telecom is basically going through these 2 points. So that means that the network of telecom is really highly centralized. What it means? That means if Telekom Serbia, for example, want to filter or block some of the websites, or for example, if they want maybe to read all the traffic and to collect information about the traffic going on, they will need to install 2 other machines near to these points, and they will be able just with those 2 machines to get a lot of traffic that is going on. Yeah. On different networks, it's a different situation. Okay, so for example, in Amres, because it's not so centralized network, if you want to track what's going on, then you will need to track here and here and here and there.
At many points.
In telecom, it's much easier because it's like centralized.
Yeah, and I think that there is already some filtering in Amres on a local level. So every university has, every faculty practically has a list of websites that they block. For instance, I think that they don't allow YouTube or something like that.
I think BitTorrent on some of the universities is forbidden.
What's filtering? In general, filtering is controlling what goes to the end user, or whether the end user or you at home will be able to access some website on the internet. It's done in many countries like Turkey and Russia, India, Pakistan, and some other countries as well, under the pretext of national security or child pornography, one of the most common excuses. But what I want you to think of internet filtering, that it basically is censorship in a way, because the government or any government in the world tries to filter or prevent access to some websites that are considered inappropriate for that culture, political system, etc. There are many ways to go around these filterings, but I'm not going to get in that now. It's important. Why it's important that the internet remains decentralized? Because if you have a network that is highly centralized, and the central point or some point near the center gets corrupt in any way, gets hacked or whatever, the entire network is compromised, because in that point you have everything, all the traffic passes through that point. For example, in telecom, if you have a decentralized network, if part of the network gets corrupt or hacked, the other the remaining part of the network can work properly. So that is why it's highly important that we fight for decentralized internet and neutral internet, as opposed to the balkanization of the internet, one of the most sorry excuses for a term, which means that every country gets sovereignty over their own part of the internet, which means that, for example, if the Russian government decides that no Twitter for a Russian citizen, they have a legitimate right to do that. Now that's unlawful. So this is the central point where these providers merge. It's called SOX, or Serbian Open Exchange, which is the first and, as far as I know, the only successful internet exchange point in Serbia. It's operated as an organization, and they have their own hierarchy and way of controlling.
So basically, you saw the networks individually. Now those like visualization is going to show how those networks are interconnected between each other. So that's basically the internet.
For example, your friend is on telecom and you're on SBB. In order for you two to be able to communicate, their networks need to merge at some point. This is basically that point. Another important thing for us was to see what the Serbian citizens actually visit online. There is this website called Alexa. It's run by Amazon. It's owned by Amazon, which maintains lists of most popular websites per country. So we got the list for Serbia. We took the 100 most popular websites, and we wanted to see where are they hosted, where they're actually physically hosted. So the reason for this is that we wanted to just make a route like we did for the Facebook packet in the first story, to see through which countries you go when you're sitting at home and browsing some website on the internet. Because we seldom think of, it's really hard to think of leaving the country when you're in your own apartment doing something online. You don't get the feeling that you actually not only get out of your home, but you, in most cases, leave your country or even your continent. You go to the US, and we are not really aware of that. And it's super important to be aware of that, because changes in laws in all of these countries affect us really seriously. So the yellow line which you can see around here is the national border of Serbia. All the websites that are inside the yellow line are in Serbia, and all of them that are outside are outside of it. So basically, on the first view, you can see that most of them are outside, but let's just have a couple of things around here. There is a high centralization there is a high centralization in a couple of points in this picture. So first of all, most of the websites that are hosted in Serbia are at one single provider, hosting provider, which is called Mainstream. It's a provider from Belgrade. Also in some other providers, but just a couple of them, Unitori and Telecom, they have each one or two or three websites. So most of the websites, the representative number is 100, so we took the 100 most visited sites. So most of them are outside, but those who are inside most of them are with Mainstream. And another important thing is that you see these dots in here. It's again a centralization point, because if you visit any website in Serbia, chances are that you're going to pass through that point, which again talks about centralization. And when we talk about leaving the country, there is also a point which is highly centralized and through which you visit many websites, like this one or maybe this one here. So most of them are interconnected and highly centralized, which means that at some point somebody sitting somewhere can know what websites are visited by a huge number of citizens of Serbia or people who live in Serbia at any point of time. So as I said, just a little bit of statistics. Again, I mentioned copying data and storing data and data retention I hope that you're clear with the term, but I'm just going to repeat the explanation once again so that I'm sure that you know what it is. Data retention means that the country makes a law that asks for the ISPs or the telecom operators that they store data about your activity online for a certain period so that they can use that data in case there is a court process going on and they need some evidence. Most of the excuses are organized crime, smuggling, child pornography, and terrorism, international terrorism, which are quite a poor excuse for data retention because studies have shown that data retention is not an effective technique fighting terrorism or any other type of crime, so to speak. So let's just have a closer look at that. These blue points on the right is your source computer, and on the left, the blue points are the points where the data your data practically when visiting those websites is copied. So we see a huge concentration of these blue, and the white points are where the website is actually hosted. So we have a huge frequency of these blue dots in Budapest, Vienna, and Frankfurt. So at these points, these governments, the Hungarian, Austrian, and the German government can easily see what interests Serbian people have because they have all the data that are retained in their points. What we can see is that most of our data passes through EU and ends up in the US. Just a little bit of statistics, which I personally don't like, but it's useful sometimes. Only 27% of the websites in Serbia are hosted in Serbia, basically. Only 14 of them are hosted with mainstream, which means that 14 out of 100 or 14% is quite a high percentage for a single hosting provider. Then the entire you can't see it's actually 13 because of I'll try to do that. The number of countries in which you go when surfing online, chances are it's 13 or less. 17% of the traffic passes through in 17 cases out of 27, the traffic passes through SOX or Serbian Open Exchange. 65% remains in the EU, 48% is in Germany, while 11, this is a really fun fact, not really relevant, but quite interesting. 11 websites, or 11% of these websites are hosted in the Netherlands. That's the reason for this is that the Netherlands or Holland has quite liberal laws regarding pornography. So these are mostly internet pornography websites. 36% of 100 most visited sites in Serbia are in the US. So this is the map. So it's also quite centralized because it doesn't it's only in Europe and in the US. We don't really go to Russia, I don't know, Australia, Africa, South America. The Serbian internet, or the most popular websites in Serbia, can be put in this one box of Europe and US countries, even not all of the European countries, but some of them. So we also can see that we're quite centralized in this way again. And now we come to one really, really fun story. You have heard the word cookies. You probably like eating cookies, but there is also another type of cookies there are on the internet. Cookies are pieces of data that contain some information that can be related to you in some way, so that the next time you visit your website, you have better user experience. That's your location, your, let's say, username, in some cases your password also. So they contain data that gives some really, really sensitive and important information that can be related to you. most of the websites use cookies, and it's because it's quite convenient because they use Google Analytics, which is a Google service that allows the web administrators to track the number of visitors, see where their visitors come from, how long they stayed on the website, and other information, how many clicks they had on certain links, and other information that are quite useful for them, but they're really intruding our privacy. So why should Google know how long do I read a single text? Or why should Google send me advertisements at all? Because the purpose of these cookies is to make a profile of every user so that they can send them certain type of advertisements when they're online. You have certainly noted that when you Google something, then after some time you get on the side of your browser advertisements related to your search. For instance, if you, I don't know, Google rent an apartment in Novi Sad, then you get booking.com telling you that there is this nice apartment in Novi Sad or near Novi Sad or whatever. This is based on cookies. So the business model of most of the biggest internet companies nowadays is not making you pay for the service, but offering something and getting your data, which is their currency. The entire amount of the value of data on European level 2 years ago was 315 billion GBP pounds, and until 2020 there is this estimate that it will reach $1 trillion, which is a humongous amount of money. It's not the money that you get, but it's amount of money that some company gets for using your data. In most cases, this company is Google. It's been deployed in many websites. So these are the websites in Serbia that implement cookies. This Gazeta Express has the biggest number of cookies. Then you have Krstarica, Telegraphy, etc. So in the middle, we have the types of cookies they have. Of course, the most common one is Google Analytics because of the reason I already told you. Then we have Facebook. The Facebook cookie goes in many different shapes and sizes, from share button to like button to Google to Facebook comments and other content they provide for free for the websites.
Maybe to make story again a bit more simple. You have those companies, Google, Facebook, and other ones, no? They are really, really extremely rich, okay? So they are earning like $56 billion, for example, Google, every year. That's a lot. That's like more than probably Serbia or more than a lot of countries in the world. And from where this money is coming from? So the only business model that they have is to collect data about your movement on the internet and to transform this data into some analytics. That means into some profiles. And then they are selling those profiles to people who want to advertise on their website. So the only business model that Google have is that. There is nothing else. And every time when they want to have like some new service, some new thing, it's basically to support these business models, to have more data about you. If it's, for example, Nest, this is some kind of smart thermostat for homes that can like monitor your electricity usage and temperature and other things. It's to collect more data about your behavior. That means that you are at home. That means that you prefer to, if, for example, if you are growing marijuana on the
Don't do that.
Don't do that. But if you are doing that, you will spend a lot of electricity, no? To put the lamps and to heat.
Just go on and tell them how to do that.
And basically, if someone is able to track how many electricity do you use, he is able to track you and to find you because of that. And it's basically what Google is doing, is trying to transform this information about you and to create a profile of you. Do you like this? Do you like that? And then to sell those profiles to marketing agencies and
who
other.
then in the end sell you, no, don't sell you, but show you some advertisements. This thing is going to escalate at some point with the introduction of Internet of Things, because then, or smart houses, cities, whatever, because then we have many devices that have some different sorts of sensors. For example, the refrigerator that has an IP address and some interface that collects data on how much milk you have, how many eggs you eat a week, etc. So these things get more and more personal by the day. You should take notice that Google implements many of these cookies, but in the future, this number is going to grow exponentially. That's at least my opinion. Just to have a look at the companies, of course, Google Inc. is the one who owns most of these cookies. Then we have Facebook and Genius, which is an interesting example, because it's a company based in Poland, I think, or Slovakia, in Eastern Europe anyway. So it's a company that offers marketing services for companies from Serbia. So it's interesting for this. It's really interesting for this market here, because they have the most personalized data of Serbian citizens there is. So many companies from Serbia actually go to Genius and ask them, okay, I have this advertisement here, just please send it to people who are, I don't know, teenagers, attending high school, interested in sports, and then you have Gchq or some other sport vision company that sells sneakers because they know that they play football. Just again, and then the numbers decrease slightly. 90% of the websites have integrated at least one Google cookie, 46 integrate Facebook cookie, 36 Genius, 24 Twitter, etc. 17 different, Google owns 17 different third-party applications or 17 different types of services that keep a cookie on your. The important thing to know is that the cookie is not on the internet, but on your own computer. So every time you access the website, you send the cookie along with the request to their website, and that's how they analyze it. There is 118 in the 50 most popular sites in Serbia integrated Google party applications. 90% of them are integrated in 45 out of 50.
So what it basically means, it means that even you don't use Google, and that's probably not possible, but even if you are not using Google, when you land on 90% of the website, there are Google cookies that tell to Google that you are on the website. And
yeah,
so lots of different things.
Basically, that means that once instead of visiting one website, on average, you visit 7.3 other websites as well. So, because the average number of integrated cookies per website is 7.3, which means that you don't only visit the one website you actually type the URL address of, but you also visit 7.3 other websites. So 8 different servers on the internet, almost more than 8, servers on the internet know that you visited a certain website or certain type, that you're interested in certain thing. I'm not going to go too much in detail regarding this, just yeah, I think we could skip this, because this is an interesting one. It's the proportion of where these companies that own the cookies come from. So you can see this big black stripe, it's the US, of course. Then we have Serbia somewhere in here with this small stripe, and not many other. We have Poland, this because Genius is in Poland. So the only influential actor in Serbia regarding cookies are the US, because most of the companies are actually registered there. So this is something Vladan is going to talk about mostly. I'm just going to jump in a moment.
Let me try somehow to make some kind of summary of the things before. First, we understood like when we are visiting some website, we are traveling to 7 different countries, leaving our trace on the way, and other countries on the way can collect the data about us. Okay. Most of those countries that we are visiting are across the ocean, so it's United States, and the rest of the countries in EU. So our internet is not so big. It's basically Serbia, EU, United States. Then we realize when you are visiting some website, there are other people who have information that you visited that website. And then we realize that this is the main business model of the biggest internet companies that exist today in the world. So they are able to collect a lot of information about you. So, okay, basically who are the players? Who can collect? Internet service provider can collect information, government can collect information, and companies can collect information. And also they are redistributing this information to other companies. This is some kind of summary of the things. And through this, what we explain now, they can collect information of which websites we are visiting, how long we are staying, or what we are clicking, what we are searching on internet, so on, and they're using this information to sell you more things. But this is not the end of the story, of course, because there is a mobile phone. Mobile phone is basically the biggest tracking device that exists, that ever existed. So it's the most ultimate surveillance device.
Let me just check one thing. Who here has a smartphone?
So,
Great.
we will explain why this is scary on the story number 4, but this is story number 3 or 4, I don't know. So, when you are downloading an application, you are clicking something like this. Do you accept? Yes, 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 I accept, I accept, I accept. And more or less, you're never reading basically what you're accepting. So we did some kind of research. So we studied the most popular applications for mobile phones and tried to analyze what kind of information you gave them permission to collect from your mobile phone. And so, for example, Facebook. What we can see here, okay, go back. Okay, they can collect location, SMS, phone, photos, media files, camera, microphone, Wi-Fi connection, device ID, call information, other things. But when you go deeper, more into details, you basically understand that they can collect more or less everything that exists on your phone. Maybe they're not collecting this by purpose of like tracking you or something, but in any case, you gave them a possibility to do so, if they want. And this is the same, for example, with the Google. Google is collecting, again, like 1 zillion.
Oops, no.
Go back. 1 zillion of things, different permissions, okay? But for example, you have Bing, application made from Microsoft, for example, that is doing the same thing, and you can see that Bing is collecting much less, they are collecting less things than Google. So basically for the same service, they are not collecting so many things. And then you have DuckDuckGo, that is basically like privacy-oriented browser. They are not collecting almost anything. So then we start to research like some kind of domestic application, like mostly news for like Kurir, Mondo, RTS, Novosti, B92, Blitz, and so on. And then we found like also interesting things that, for example, Kurir can read sensitive log data. What it means, sensitive log data? That means when did you call someone, who did you call, how long was duration of the call, and so on, so on. And Kurir, one news website, can collect those information about you. Why they need that, I don't know, but they are doing that. But what is also like really scary on this, it's that when you are like buying from, I think, Telecom, a mobile phone, the courier application, it's already pre-installed. That means that you never gave them approval to do that. It came with the phone. So this is the things that you should always have in mind. When you are installing some application, please do read what is written there, because this is the price you are paying for free apps. Okay? So the most intrusive applications that there are regarding these permissions are, of course, this Viber, WhatsApp, Facebook Messenger, so on. Every time when you hear that Viber, for example, it's a company that it's worth, I don't know, $50 million or sell for, I don't know, $200 million, you should ask yourself, based on what?
They don't produce anything.
The application is free. They don't produce, I don't know, from where those $50 million came from. In most of the cases, it's coming from the data that they are collecting and selling to some, or for marketing purposes, or to some other companies. There is no any other business model. So this is Viber. So all of those things, visualization and stuff, you can see on this website that we made for this research. It's called labs.rs. So you can go in detail and try to understand all of these permissions. There are privacy-oriented or anonymity-oriented softwares, applications. For example, Orbot, that is some kind of mobile version of Tor. Yeah. That are basically not collecting anything, just what they really need to do to run at the startup, to have full network access, and to view network connections. Okay. And this is and then, for example, if you are installing application, for example, a clean master that should clean your mobile phone from different kind of dump and things, you can also check what they are doing on the back, and you will understand that they are collecting a lot of different information about you. So this is basically some kind of summary of our mobile phone permissions analysis. And now we will...
And this is the intrusiveness, yeah.
This is then we try to understand which of those permissions are privacy, can harm your privacy, and basically from here to here, most of those things can be have a problem with the privacy, and all of those few little permissions are more or less okay and don't harm you a lot. But you can find more information about this. And this is our last thing. It's related to surveillance and metadata and retention infrastructure. So it's basically how the mobile phone, how they are receiving information from your mobile phone and how they are tracking your metadata. So basically you have a mobile phone. Inside of your every mobile phone has something that is called IMEI number. IMEI number, it's a unique identifier for the mobile phone. Inside of the mobile phone you have a SIM card. And most of you signed some contract with MTS or Telenor, so you're giving your name, surname, YMBG, your street address, number of other phone, tralala, la la la, okay. So they have basically information who you are. Then your mobile phone, he's doing three different things. He can do the call, he can do SMS, and he can do data transfer. And all of this, it's called GSM communication. And how things are going on. Around you, in most of the cases, you are surrounded with the three different base stations. What are the base stations? Base stations are those gray antennas all around the city, okay, or in the fields, doesn't matter. And all the time, your mobile phone is connected to 3 of them. And so when you call someone, this signal is going to the base station, okay? And then from the base station, it's going to something that it's called mobile switching center. And this is where the magic is starting to happen. In this mobile switching center, these packets, it's similar to internet. The packets, every call, every data packet, have a content, and on the top have a header. All of these headers, and headers means who you're calling, for how long, from which base station, so on, so on. This is collected, copied to something, to some kind of database of metadata. In Serbia, those companies, MTS, Telenor, and so on, they need to collect those metadatas and keep them for 12 months. Okay? And then, so you have like a lot of metadata about each of us. So for like, they have every time when you call someone, when you send SMS, when you move somewhere, do something, basically they have some trace in metadata that you did that. And they're keeping this information in some kind of database. The main question is how and who can access those metadata. By our research, there is different ways that how different agencies, or like, it can be like MUP, it can be BIA, VBA,
I
tužilaštvo or court. So all of them can access those metadata through different ways. For example, how it should be done is that they are like calling MTS or Telenor and asking them, okay, here is a court order, can you give me metadata about this person? This is like usual thing. But it's not it is part of the reality, but the another part of the reality is that they have some kind of application for direct access to this metadata. And so they can search through the database by the telephone number, by the location of the base station, and so on, so on. What it means, for example, all of you that have a mobile phone now, you are now connected to base station, no? If I search now through this database, who is connected to base station in this moment, I will know exactly who is sitting in this room, okay? And this is how they are tracking the criminals. This is how they are tracking doing like
But also political activists, journalists,
but
etc.
Because there is a different illegal ways how they are accessing this information through these applications and so on, our research showed us that like there is like huge amount of data that is analyzed on a legal way. That it's not through this court system and so on. You can see more. I think we are now at
We have 5 minutes left.
5 minutes.
So maybe.
So this is basically, you can read more on our website, and you can find out how those different MUP, BIA, VBA, and other people are like accessing to our metadata. Now I would maybe leave this 5 minutes if someone have any kind of questions about anything related to this topic.
Can you, do I have a voice? Okay. Any questions? Yeah. Maybe to Mike.
Okay, hi.
Hello.
Hi. Well, you mentioned the trouble with the cookies and tracing us, but you haven't given us any guidance on what to do about it. So, yeah,
Regarding
recently,
cookies?
yeah, about your activity on the internet being tracked and what you can do about it.
Are
as a
you
user.
asking from the position of a user how to protect yourself from
Yeah.
cookies? Great. So there is this thing called AdBlock Plus. Some of you might have heard of it. It's basically a plugin for websites that blocks the ads. So by blocking the ads, it blocks a huge amount of cookies. But on the other hand, you can configure your web browser, especially if you use Mozilla or Tor, which I strongly recommend. You can turn off the cookies. It will be a little bit inconvenient in the sense that you will need to sign in every time you open, I don't know, Gmail or whatever, because it won't store anything, your passwords or whatever you use. So just turn off the cookies on your website, use AdBlock Plus, and most preferably use Tor browser, which is super easy to download and install. torproject.org, download, use it, and you're pretty much safe.
Yeah, sure. Can I give?
Yeah.
Yeah. Recently, I found out about a nice plugin similar to AdBlock, but
Okay.
a bit more user-friendly and flexible. It's called Privacy Badger, and it's from the Electronic Frontier Foundation, so it's cool, and I would recommend people to turn it on. And the nice feature of it, you get a little badger icon, and you will see the number of cookies that it detected. So yeah, you can see for yourself, like the things that you showed us in this presentation. You can see for yourself what individual sites are, how many cookies they have and what they're doing.
I encourage you to do so.
Yeah.
Install whatever to block as many cookies as you can.
Yeah, and just one more comment, because I'm not a security expert. I'm a generic programmer, and I do some mobile development. And particularly on Android, some of the permissions are not finely grained. So yeah, technically, if they are requiring you to do that you can allow something, that doesn't mean necessarily that they are doing that.
Of course.
But, I mean, the most plastic example is, for example, you want to make a flashlight app, and that requires you to have the camera access in the earlier versions. So you see a flashlight, and why it's asking a camera for me? So yeah, these things can exploit. I give you this permission, then yeah, you can in the next release put some nasty stuff in there. But yeah, sometimes it is, sometimes it's not. So yeah.
Certainly,
I mean,
but there is also this good trend, which I'm really glad about, going on, that the applications ask for a permission when they need to do a certain task. For example, you need to switch on the torch or the flashlight, then it asks you, this action asks you to give a permission to use flashlight, camera, whatever, and then you give it, but it's not a permanent permission. So these event-based permissions are a much better approach. That's something iOS had, and that's something Android will have in their next edition. So things are getting better, but we still need a strong voice from the community. I mean, you cannot blame the developers for asking to use those permissions. You can blame it on Google and their review system, because they need to review if the application really needs to use all those things. So yeah, things are getting better, hopefully, in that way.
okay.
Any other questions, comments? We're
Thank you.
kind of running out of time, but maybe one more.
Can I speak? Okay. I personally use Ghostery, and it shows me also how many cookies do I have on a site. And one more thing about GSM and base stations. Did you know that we here have our own base station? You can connect to it if you choose our network operator on mobile phone. We don't keep metadata. Please try it. Okay.
Great. So
regarding tools, our idea with this research was to try to understand the map, the ecosystem. Okay, what's going on and what are the different forms of our behavior and how this network looks like. And basically for every different aspect, you have a probably different tool how to avoid the problem. For example, if you don't want to be tracked locally in your country, then use VPN and browse the internet from the another country if this is what you want to do. If you want to be anonymous or things like this, use Tor network. If you want to understand who is tracking you online, use Ghostery or Privacy Badger or so on, so on. We just wanted to somehow map different kinds of problems that we see and not to give solutions, but just to do awareness about the things. I hope we will maybe next year do the solutions.
But yeah, we also have a guidebook with solutions, basically.
Yeah, we have also a guidebook. But
so you can check everything on our website, labs.rs.
Okay, one more thing. Did you know that there are crypto parties that are meetings or gatherings of hackers where you can learn how to use tools for cryptography or tools for blocking these kind of trackers. We will have a crypto party here after the soldering workshop, if anyone is interested in it.
So go there, learn how to organize your own crypto party. I think you have that one as well.
Yes, there is a book how to throw a crypto party.
Yeah, so it's super simple, super easy, and you should share it among your friends. Even though, as we had the opportunity to hear last night, crypto parties are not the solution, but at this point I think that's the only option kind of we have. So just try to educate yourself as much as possible about all of this. As once again, labs.rs, check it out, it's kind of cool, and that's it. Thank you very much.